Hello everyone, this is Dr. Piraj Kumar, Assistant Professor, Department of Mechanical Engineering, KLEF. Welcome to Machine Design course. The topic for today's discussion is design of keys and muff couplings. So the aim of the present session is to make you familiar with the design of keys and design of the muff coupling. So first of all, what do you mean by keys? Why it is required? So you might have seen a shaft. Just now we have seen the design of shafts subjected to both bending moment as well as the twisting moments, and why shafts are required, what is its function. So now coming to the keys, the key can be defined as a machine element which is used to connect the transmission shaft to a rotating machine elements like pulley or gear or sprocket or flywheel. So it is, the key is nothing but it is a machine element which is used to connect your shaft to the its rotating elements such as pulleys or hub or gears or flywheels. So the shaft as well as the key should have same material. So since most of the shafts is fabricated using mild steel, key also fabricated will be using mild steel. So the slot or the groove that is made to connect the shafts and the rotating element is known as the keyway. So here you can see this is a groove or slot made. So this one will call keyway. Now you can see here this is a shaft, and shaft is held between the hub, and in order to connect your shaft as well as the rotating element, this is the key used. So now what is the major functions of the key? The first function is in order to transmit the torque from the shaft to the hub of the mating element. That is the first function. And the second function is to prevent the relative rotational motion between the shaft and the joined machine elements like gear or pulley. That is the first one is to transmit the torque from shaft to the mating member, and second one is to prevent the relative motion between them. Third one is to prevent the axial motion between the two elements, except in case of feather key and spline. That what do you mean by feather key and all? We will see the next slide. So these are the three functions, major functions of the key. So what are the types of keys available? Based on the mating location, that means like if these are the different classifications, like first one is the sunk key, saddle key, tangent, round key and spline. If you coming to the sunk key, again there are like square, rectangular, flat, there are different classifications of the sunk keys are there. The first one is like sunk keys, majorly it fits half in the keyway of the hub and another half in the keyway of the shaft. That means whatever the keyway we made like this, half will sit inside the shaft and another half will sit inside the hub. So such kind of keys we will call sunk keys. Whereas in the saddle keys fits only in the keyway of the hub. It simply sits on the shaft. That means there is no, it won't fit onto the shaft. That means completely groove will be on the only hub. For such kind of applications we will be using saddle keys. And coming to the tangent keys, it is fitted in a pair at right angles wherever heavy load need to be transferred. There we will be using the tangent keys, and each key generally they will be fitted in terms of a pair, that means two. So each key will be having unique directional torsional capacity. That means in single direction only it will control the twisting moment. And coming to the round keys, fits in the hole drilled both in shaft and hub. That means in order to connect your shaft as well as hub, one hole will be drilled, and using that hole these round keys are used to connect your shaft as well as the hub. Spline. Splines are nothing but it is shaft plus integral key. That means key also will be there on the periphery of the shaft itself. Such kind of shafts will call splines. So splines is nothing but shaft plus integrated key. So now today's discussion we will see how to design a sunk keys, because in this half of the keyway will be in the hub and another half will be in the shafts, and mostly these are the keys used for the different application. So let's see now how to design the sunk keys. So as I already told you, a key, the sunk key, in which half the thickness of the key fits into the keyway on the shaft and the remaining half in the keyway of the hub. So this is the keyway, and half will be in the your shaft, and another half will be in the hub. I told you, right? Sunk keys are like square, flat keys. These are the different classifications. Here if you see, the width B is nothing but d by 4, that means depth by 4. H is your depth is nothing but 2 by 3rd of width. D is nothing but your diameter of the shaft. L is length of the keyway length. It is generally we are taking L is equal to 1.5 times of diameter of the shaft. So these are the standard dimensions we are using for the your flat key. And coming the square, because for square your both width as well as the depth, it should be same. So B is equal to H is equal to D by 4. This is the standard, and length of the key is nothing but 1.5 times of the diameter. So these are the standard dimensions we have to consider while designing the sunk keys. So now, okay, now we know that what are the dimensions or what are the numbers we have to take for designing a sunk key. So, but what are the stresses or what are the loads that will act during the servicing of the during the running conditions. So if you see here, this is the key, like here if you see F force as well as F1. This F is due to the torque transmitted by shafts. So since shaft and your key is integral parts, that's why this is also should transmit. One of the function of the key is nothing but it has to transmit the torque. So because of this F force will causes the shear stress, it will causes the shear stress. And this because of this F1, because since half of the part is in the key and half of the keyway is in the hub. So because of this, whenever this F1 load is acting upon this key, it is subjected to the compressive stresses. So what are the forces that are, what are the stresses that are acting in the key? First one is because of S, shear stress is inducing, and because of F1, compressive stresses are inducing. So you can see here the failure of the key either can happen because of shear failure because of F force, or can happen crushing failure. So whenever the exact center location, because the shear area and this crushing area will be different because of this F1. So we have to evaluate the design of the key for a shear failure as well as the crushing failures we have to evaluate. Now coming to the design of square and flat keys. So now consider the shearing of the key. I told you right already, the area of cross section for shearing action as well as the crushing action is different. If you see, this is subject to the shearing load. So here what is the area? Length into width. Length into width is the your shearing area. So force is nothing but your area into shear stress. So length into width into shear stress tau value. So we know that the torque is equal to force into distance. So by substituting this force value in this equation, you will get the twisting moment for the key subjected to the shearing stress. So whenever we are designing a key for a shear stress, our equation should satisfy this, our value should satisfy this equation. This is the first one. And next one is the for crushing stress. So what is the crushing area here? This is your marked one is the your crushing area. So what is the area? L into T by 2. T is nothing but thickness of the key by 2. So L into T by 2 into sigma C. Sigma C is nothing but your crushing stress. So by substituting, torque or twisting moment is equal to force into distance by 2. This value we will get this is the equation. So while designing of the keys, we have to consider first one is the shear failure, second one is the crushing failure. If the given value satisfies both of these equations, we can claim those values are correct. So that is with respect to keys. Now coming to the couplings. So what is the function of the couplings? Couplings are majorly used to connect two shafts. So again, coming to the classification of the couplings, majorly here two types we are going to discuss. First one is the rigid coupling, another one is the flexible coupling. So you can see here the rigid couplings, it is used to connect two shafts which are perfectly aligned. That means these are the couplings we can use to connect the two perfectly aligned shafts. Why? Because now assume one shaft is of 2 meter, another shaft is of let's say 5 meter. Now in order to make a shaft of 7 meter for some application, we can use these couplings to connect both 2 meter shaft as well as a 5 meter shafts. Instead of making or instead of purchasing new 7 meter shaft, we can club both 2 meter shafts as well as the 5 meter shafts using these couplings. So what are the rigid type couplings here? First one is the sleeve or muff coupling. So this is the sleeve or muff coupling. So you can see here, this side will be one shaft, another side will be another shaft, and using this arrangement we can join the two shafts. This cut we will call the keyway. You can see here, the cut whatever made here on this hub is known as keyway. Second one is the clamp or split muff or compression coupling. This is one. So you can attach the shaft here and you can use tight, you can tight using this arrangement. So you are splitting and then connecting. So split muff coupling. Third one is the flange coupling. So this side one shaft will be there, this side another shaft will be there. These two shafts are connected using this flange, and these two flanges are connected using your bolt and nut assembly, your bolt as well as the nuts. So how many number of bolts we have to use, how many nuts we have to use, it will be depends on the diameter of your input and output shafts. And another classification is the flexible coupling. So the name itself is indicating it is used to connect two shafts having both lateral as well as angular misalignment. That means here these rigid couplings are majorly used to connect the shafts which are aligned, whereas these flexible couplings, they are used to connect the shafts which are misaligned or lateral alignment also. First one is the bushed pin type coupling, universal coupling and hold arm. You can see here the universal coupling, because here one shaft is in this direction, another shaft is in this direction. They are not perfectly aligned. Still we can join those shafts using this universal coupling. Here also same case. Hold arm coupling, this is the arrangement. This in between is the arrangements which are used to connect offset parallel shafts. Hold arm coupling we can use for offset parallel shafts. Universal coupling we can use for the misaligned, offset, everything we can use. That's why the name itself is universal coupling. So now what are the components here in the coupling? The first one is, if you see, this is the arrangement, and these are the different parts in the entire unit of the sleeve coupling. First one is the input shaft, output shaft, then sleeve, and then keys. This is the key, this symbol, this is the key. What are the components? We have to design, we have to do the design for the design of shafts, we have to do the design for the design of key and keyways, and then we have to do the design of sleeve. So what are the components here? If you see, the length of the sleeve, we can write L is equal to 3.5 diameter. Similarly, the outer diameter, okay, the outer diameter of the sleeve can be written like 2D plus 13 mm. So we know that since the shaft is used to transmit the torque or twisting moment or the power, similarly the couplings also will be transmit the power. So here for a hollow section, because sleeves we will treat generally like it is a hollow hub. So for that, using the standard equations, the twisting moment is equal to pi by 16 tau c d power 4 minus d naught power 4 by capital D. Here the C indicates the coupling stress. C indicates the shear stress for the coupling. So from this expression we can calculate the outer diameter of your coupling sleeve. So once you got outer diameter, you can substitute here, you will get the small d. So this is how you have to do the design of shafts, design of keys, design of coupling. So like first step is we have to calculate the diameter of the shaft, as I told. Then we have to calculate the dimension of the sleeve, that means outer diameter as well as the length of the sleeve. Once these two values are found out, then we have to calculate what is the torsional shear stress inducing in that member. So and then the length of the keys. Once everything we have calculated, then we can verify the diameter of the shaft. Whatever value we have taken during the designing, that value can be okay or not. We can design using all the three design criteria. First one is the design of shaft, design of keys, design of your muff coupling. So now we will try to discuss, like this is This is the design data book for sleeve or muff coupling. These are the standard values, whatever just now I showed in the previous slide. The outer diameter, the length of the sleeve, the twisting moment formula, everything it is given in this. So you can access this design data book by PhD College of Engineering, Coimbatore, for any values, any standard values and standard input parameters. So let's see one problem on this. Design a muff coupling which is used to connect two steel shafts transmitting 40 kilowatts at 350 rpm. So what they are saying, we need to design a muff coupling to connect two shafts which are used to transmit 40 kilowatt power at 350 rpm. So they have given power, they have given the rpm. Now what they are assuming? Assuming suitable material for muff shaft and key. When the muff coupling design will be completed, once you do the design, satisfactory design for your muff as well as the shaft as well as the key, if the component is suitable, or if the whatever diameter of the shaft you have taken, if it is satisfying all the three failure criteria, then only you can say this is the diameter of the shaft that can be used for the muff coupling application. Like that we have to do the design. So now first step is designing of the shafts. So how we can do the design, because since it is only subjected to only twisting moment, what is the equation we can use? We can use the torsion equation, and by substituting all the values in the torsion equation we will get twisting moment or torque is equal to pi by 16 into tau s. S stands for shaft, tau into d cube. So the twisting moment, since power is given and your rpm also given, you can calculate the twisting moment. Once you calculate the twisting moment, since the shear stress is given already for a particular material, if not given, you can take the standard values from the design data book. Then you can calculate the diameter of the shaft. That is the first step. Now coming to the design for sleeve. So how we can calculate? First, while calculating the design for sleeve, we have to calculate the outer diameter of the muff. So capital D is equal to 2D plus 13, that, and length of the muff is 3.5 times of diameter. Since the shear stress will be induced in the sleeve, we can have to calculate that shear stress. Twisting moment is equal to pi by 16 into tau into these values. Here capital D is nothing but 2D plus 13, small d is nothing but your diameter of the shaft. So by substituting this value and twisting moment, you will get the this allowable tau c value will get, which is induced inside the material. If this value is less than the allowable limit, then we can say your design for sleeve is safe. If this value is greater than allowable limit, then your component will be failed and it won't sustain your applied loads. That is the second one. And design of the shaft is, you know how to do. Design of the sleeve also you know how to do. Next, design of the keys. As I already told you, the design of the shaft and key, the key will be subjected to the crushing as well as the shearing failures. So if I consider the shearing failures, what I can write? The torque transmitted T is equal to L into W into tau s into d by 2. So from that equation we will get the shearing stress. Similarly, by substituting in the crushing stress equation, we will get the sigma cs, the stress developed inside the shaft due to crushing loads. So if the developed values are less than the allowable values, then we can say the design is safe. If it is not meeting that values, then we have to reconsider or redesign the entire your shaft, key and your sleeve. So these are the different textbooks for the further learning, and thank you.